Greetings, everybody. This is Eric Andelin, Senior Workflow Advisor with SimActive, and you're joining us for the webinar, Can RTK PPK Really Remove the Need for GCPs? And with me, I have my guest, Chris Greene, UAS Manager with Bullseye Construction. Chris, say hi to everybody and give us a little bit of your background.
Hey guys, operating out of Charlotte, North Carolina, contractor here named Bullseye Construction. Been in this for about 5 years. Mostly have a background in law and got out of the industry 5 years ago and started the program here. Been operating it as a solo pilot, mostly just for the purpose of flying the sites, getting progress reports and volume calculations, dirt estimates, things like that.
Excellent, excellent. And I mean, when you're working with drones in the construction environment, that creates a whole bunch of different challenges, and we'll get into those. But the topics that we're going to cover are understanding RTK or PPK for drones, supplementing with ground control points, managing accuracy with Correlator 3D, and then confirming the quality of results. So let's talk a little bit about understanding RTK and PPK for drones, what RTK is and what PPK is and what the difference is. So Chris, having that background, can you fill us in a little bit on your end, what the two are?
Yeah, I guess I'll start with the RTK, and that's it's when this is really when you're getting corrections in real time from the drone to a base station, whether it be an on-site base station or a state base station, which is what I use mostly.
Mm-hmm.
The North Carolina BRS has a pretty robust network, so I'm not overly confident in it, but I use it, and I've gotten decent results.
Yep.
On the other hand, PPK is post-processing the data and using an Opus solution. And in that vein, sort of waiting for the ephemeris data to perfect itself might take 1 or 2 days.
Mm-hmm.
I don't use that solution a great deal. Mostly my workflow centers around taking a rover and a base on site and shooting some control points and getting my accuracies that way.
And honestly, I mean, you're already out there, so it kind of makes sense, you know, that you've got that base in your rover with you. If you're using an RTK solution, correct? I mean, it has to stay connected. The telemetry, it has to be connected. If it doesn't, then, you know, you're out of luck and you kind of got to start over or figure out.
Right. And that's one of the, that's what I consider one of the downfalls.
Yeah. Yeah.
Because I have lost connectivity and I'm using a hotspot on my cell phone.
Mm-hmm.
And sometimes it's just not the best.
Yeah.
Yeah.
And I know
I've had to redo sites.
Yeah, I know from our experience, you know, in work that I've done in the past, especially here in Florida, there's places that you'll be hard pressed to get a cell signal or anything like that. So
Mm-hmm.
it creates that challenge as well. The big difference between the two is that PPK is a post-process solution, and you can run with what you've got after you land and you just run your post-processing. But if you want actually super tight results, then you need to wait for the ephemeris data, which, like you said, could take a day or two. That's a challenge. On the construction, give me just, what is a typical project like for you?
Yeah, good question. Most of our projects range in size from 20 acres to 200 acres. And the ones that I'm working on now, I have two really, and one is actually about 140 acres, the other is 60 acres. What I'll do is I'll go out there. The first thing I do is set up my base and rover, and I'm going to survey that site using control points. And what I try to do is keep those within about 500 to 700 feet of each other, get a nice triangulation across the site. For example, on the 60-acre site, I'm typically using about 10 of these.
Mm-hmm.
And I'll use an observation period of 2 minutes on each of them, throw down a mesh target, and then conduct my flight after I get done that process. Typically, shooting control is anywhere from an hour to 2 hours, depending on the site.
Mm-hmm.
It's a lot of walking. July in North Carolina is pretty hot. So I mean, that's one of the drawbacks of doing what I do, but I trust this workflow more than any other. I've been using it the whole time. And I actually spoke on this subject in Vegas last year
Yeah.
about the benefits of using GCPs versus, a lot of people in the industry are saying now, well, you don't need them. Fly your drone RTK, get some checkpoints and 1 or 2 checkpoints on a huge site. And I'm reluctant to rely on that.
Yeah.
And I really like to get my accuracy really tight using the GCPs. So from there, I fly the drone and I take the photos and I bring them back here and I throw them in SimActive and I let the engine do its thing.
Yeah.
And typically, I think I've been using you guys for about 3 years. I've only seen one survey during that time where my accuracy was outside of 1/10 of a foot using this workflow. And it's really been good to me. And what my job here is primarily is the owners want to know, how much dirt do we have left? How much did we move during this billing period? Itemize these stockpiles for me and that sort of thing. Everything dirt is what I do.
Yeah. I mean, a lot of people, when they first jumped into the drone business, that was their thing, volume calcs. And you're doing much more than that because there's stockpiles or waste piles, for movement of dirt, but you're also that entire 60 acres, that entire 80 acres, you're coming back and you're checking that and saying how much has been moved, because there's a cost to that, to haul it, to place it, to store it, all of that stuff. And I got to tell you, I feel for you. I did all my Army days at Fort Bragg in North Carolina, and July July through October is as bad as Florida.
Yep, exactly.
Definitely. So now, are you still working? Do you run on to occasions where you're working in a local coordinate system, or most of your projects just tied in North Carolina, tied to the VRS and tied to the state network?
That's a good question. Every single site of mine is in a local coordinate system.
Okay.
And what I do is we hire a surveyor to shoot some surveyed points even prior to beginning any digging on a site. And the next step is me going out there, and I use Trimble products. I'll take my rover and I'll set up a base out there, and I'll calibrate the site based on the control points that the surveyor has set. And then I'm in a local coordinate system.
Yep.
From there, we get a model from our model maker, and I'll load that model in our machines, and we're ready to go.
Okay. So you again, you're just the part that goes out and gets the aerial photos, gets the surface, the measurement, all of it. You guys do much more than that. You are actually moving dirt.
Oh, absolutely.
Yeah.
We're a site contractor. Everything from clearing the vegetation all the way up until vertical comes in and starts actually building the homes.
Yeah.
And so it's paving, it's utilities, it's everything.
Yeah, so you're, as a company, you're on a project for quite a while from start to finish.
Oh yeah.
Yeah.
Probably mostly around 24 months for a 60-acre site. And that's a conservative estimate. Yep. Typically it's a little bit longer.
Yeah. And on a greater scale for people that they don't understand maybe is that almost any time any dirt is moved, you've changed the watershed in that environment. And, water's going to flow somewhere else. And, it has to be accounted for. And that's why it's so important when somebody goes in and puts a Walmart in or anything like that, that, that this type of work is done, because that's ultimately, if it's not, or if it's done poorly or anything like that, you're going to end up with places like South Florida where we flood all the time. Yeah. When they talk about rampant growth, it's things like that create those issues. So I'm so impressed that, you guys do more than just fly drones. You actually do the whole thing, from moving the tractors, moving the dirt, all that stuff, actually really understanding survey. That's impressive from our standpoint, because we do work with everybody. We work with people who just, they just want to fly, they just want to make a model, anything like that. But it's always great when we have a unique story. And to that, you're also in North Carolina, which, is a pretty strict state when it comes to survey, and well versed in it. So, you know, those relationships are important to folks like you guys. So um, so we talked a little bit about GCPs, and you're right. I remember it was at UAV Expo when you did this.
Yes,
Yep.
that's right.
Which isn't it kind of ironic that UAV Expo is like the same week or the week before Trimble? So
I know.
they
You're right. I
have
don't usually go to Trimble. They give me one trip a year.
yeah.
So
The perks of going to Trimble are on a much greater scale.
oh
But
yeah.
you can get lost in the fray there. But um,
Mhm.
you talked a little bit about GCPs and how you go out and you set the rover, you go measure, you spend time on points so that you're actually getting, you're letting it soak and you're getting a good accurate reading on that point. Um,
Right.
so, those are things that people really need to think about. You don't just go throw out, propeller panels or something like that and, just anywhere and, expect that you're going to get great results. You could probably get good results, but boy, if you have an issue and that panel's not there anymore, um, you're not going to be able to go back and redo that. So,
Right.
things to
Yeah,
think about.
it's funny that you mentioned propeller because when I started this, that's the first company we used.
Mm-hmm.
And they, of course, have what they call the arrow points, which are mini base stations, according to them,
Mm-hmm.
and obviating the need for going out and doing what I do. And I just felt like I didn't have a lot of control in their process because I would send everything and they would send it overseas to their processors
Mm-hmm.
and return a product to me within 24 to 48 hours. They were pretty good about their timing, but I felt like I lacked control over the whole thing. And plus, using my workflow now, I feel like it's more cost effective.
Yeah.
I'm not relying on anybody to create my services.
Yeah.
And I feel like it's a better workflow for me. So we stopped using them.
Yeah.
Not to knock their company. They've got a great product. It just wasn't for us after a period of time.
Well, and you're absolutely right. There's a time and a place for things like that. Just like some people offload their mapping to something in the cloud. It's a choice, and
Right.
technology is neat. It's a good idea, and you can probably perfect it, but um, it's interesting. I can say that. And then you also have when you go out and do your surveys, I would imagine that in a lot of cases, you're not in a place where you can set a hard target, or at least all the way around the project. Is that true?
True.
Yeah.
Absolutely.
Yeah. And
Especially at the inception of a site when they're still clearing.
right. And one of the biggest challenges I would think working with GCPs on a construction site is there are always things moving. And they're big and they can run over targets and they can run over laths so you don't know where your point was and things like that. So you have to really be conscious about where you place those points. It's not just a case of where do I place these points around a project to get a good solution, but it's also I have to do it in a way that it's not going to get disturbed.
Yep.
Yep.
Yeah. And because of the nature of our work, a lot of times I'm shooting new control every single time I fly.
Mm-hmm. Mm-hmm.
Just because things get destroyed very routinely around here.
Yeah.
And I always tell my guys in the field, if you run across one of my stakes, feel free. If it's in your work area,
Yeah.
take it out. I don't want to hold you up,
Mm-hmm.
and don't even have any regret about it.
Yeah. Well, work goes on. So yeah, you don't want to be the
Yeah.
person impeding that. And uh, after we have our conversation, I'll go into a little bit of a demo And, I'll cover some of these things with folks on, how you should set your targets, where you might want to do that and all that. And you and I have had quite a few discussions as you came on with Correlator 3D. And I'm always more than happy to help because I learn from you as well. Well, let's go back to the RTK and the PPK and the GCPs.
Mhm.
The reason you want GCPs is because if anything becomes an issue with the RTK or the PPA solution, like you said, if you're in an area where you don't have connectivity, or if some reason down here NASA shuts down the course network or something like that, and it
Yeah.
happens, um, you can always fall back on control points. In fact, you don't need the RTK or the PPK. The control points will get you to where you need to be. So it's nice to have.
Yeah.
I'm sure you've run into that where you know it's and you also talk control. When I talk about control points, I also mean checkpoints. They can be either one.
Right.
Control points you want to be visually identifiable. Checkpoints you would prefer that, but sometimes they're just vertical, and they don't necessarily need to be
Exactly.
that. So um, when you survey a site like a 60-acre site, how many points do you throw out again? How many you consider as checkpoints? Do you, kind of rotate them in and out to solve the
Yeah.
solution? Yeah. Mm-hmm.
Typically 10 GCPs, pure control points that I use in getting a solution,
Yeah.
and probably 6 or 7 that I use as just checks.
Yeah.
And I'll spread those. I'll try to get the corners and some in the middle on those checkpoints,
Yeah.
as well as the control points.
Mm-hmm.
And I can use those interchangeably.
Yeah.
If I feel like one of those didn't work out well for whatever reason, and things happen.
Mm-hmm.
Um, and I have seen sometimes where the receiver at the top of my pole moved a little bit, and it causes an error.
Yeah.
And I'll just eliminate it as a checkpoint. Excuse me, eliminate it as a GCP.
Yeah.
But I can also throw in one of those checkpoints and consider it a GCP
Mm-hmm.
because I use the very same process when I measure those.
Yes.
Same observation period, same marking, everything.
Yeah.
And it's good to have that because when you're going through a process of getting your deliverables and you see, well, this isn't working out as well as I thought, then you can go back and play with it a little bit and come up with the right and final product.
Mm-hmm. Yeah. So that kind of goes to the next step in the process that, once you have aerial imagery captured, you've got your survey, then you're bringing it into Correlator 3D. You're creating the
Yeah.
project, and again, I'll go over it in the demo. It's pretty straightforward, but you bring in the images. If you have a RTK or PPK post-process solution, then you're going to use that file for your orientations, and it'll give you X, Y, Z, and maybe sometimes omega, kappa, and phi. But
Mhm.
you would use that instead. Yeah, you would use that instead of the EXIF data from the drone.
Right.
That is supposed to be more accurate, and it definitely is. Um, when I said omega kappa phi, the challenge for people is that that would come from an IMU, and there is somewhat of an IMU in these drones, but they're not to any quality that you would rely on them. So if
That's true.
if you run a RTK or PPK solution and you say I'm going to put one checkpoint in the middle of this project and I expect it to hit, that's really hard to do because it doesn't necessarily take into consideration good rotation of
Right.
the images. So that's one reason we suggest having checkpoints. But in correlated 3D, you have some options when you get to once you've set up the project, you put it in the coordinate system you want. You add the geoid offset if it's not already in. You can do that into the solution, and then you get to AT, and you have some options. So you have full AT, and then we have RTK PPK enabled.
Assisted. Yeah.
Yeah, RTK PPK assisted, and so and Full AT is the assumption that you've got a high quality IMU, high quality RTK information, all of that. And you're basically telling the software, don't make any adjustments, just run it and we'll get a good solution. But again, most people don't have that kind of equipment. So RTK, PPK enabled does the same thing, but it lets the software adjust for rotation. So it holds XYZ, it lets OPK float. And that's probably going to give you a better bundle adjustment and most likely get you closer to the control. And again, those are checkpoints at this time. If you run into an issue, then like you said, you can convert them to GCPs. So,
yeah,
some of the common results that we see, for example, in the AT solution, if it's measured against GCPs, and we're talking about running RTK or PPK, if it's measured against GCPs and they fall within the vertical accuracy requirements, there's no need to change anything. Everything's good. You in my world, you got lucky. Your RTK or your PPK solution was outstanding. Your project was flat or something like that, and good for you, you nailed it. I would start checking the other points. Then the next situation is the AT solution is measured against the GCPs, fails to meet vertically, or fails to meet the accuracy requirements, but vertically it's on point. So you've got a 12-foot difference in your GCPs and where your surface is. Well, that's probably a geoid offset that was missed.
that's right.
And you put that in. If you're down in the foot range, then that's probably a bad point somewhere in there, or just a local adjustment you can make, so you can fix that. And to find your difference between the ellipsoid height and in what was used in the GPS and the geoid, there's websites for that. So you can go to NOAA and get it. You can go to UNAVCO and get it. We're all familiar with those, and I think that's even going to become easier soon enough. And then again, the last is if the AT solution is measured against GCPs and it fails to meet vertical accuracy requirements, but is not consistently vertical in error, that again means there's a bad point somewhere. And like you said, you can take what was a checkpoint and make it a GCP and eliminate the GCP that's bad, and you might have solved it right there. And then you can just say that's a bad point. I always say, when we did big projects in photogrammetry, we would run into situations like that, and I called it whack-a-mole. You would start looking for that bad point.
It feels like.
Yep. You look for that bad point, you find it. Once you find it, you pull it out and verify it and try some other solutions. And I would assume you do the same.
I do.
Yep. Yep.
Sometimes frustratingly.
Oh, very, very, very. Yeah, that becomes an issue. So, when you run into an issue, and you and I have talked, what's the issue that you run into more often than not?
User error for me. Honestly, it really is. And I had this the other day, and I had a job site that I flew, the 60-acre one. And I came up with a solution, and my RMSE was around 0.8. And I've never seen that. Scratching my head, playing with the GCPs. And finally, I just said, I'm going to go do it again. And I couldn't figure out the problem. I went out and I did it again just yesterday. And I came back last evening, and I got a 0.07 on my accuracy. So clearly something happened. And what I think happened was, I think my receiver rotated, and it was causing these huge errors for some reason. I don't get all the technology sometimes, but I know, because when I went back to my truck and I got done with my last control point, I noticed that it was a little bit loose. And I thought in my head, this could be a problem. And sure enough, it was. So I had to go through the whole thing again. And I have very seldom run into problems with any of the softwares that I use, like yours.
Mhm.
And it's typically something that I did. Maybe I fat fingered when I'm creating the CSV. I might have input, instead of 720, 820 or whatever, entering a wrong northing, easting, or a Z value. But typically it's my fault,
Mhm.
admittedly.
Well, one nice thing about that is you're doing the whole process, so you can
Yeah.
find that. Because man, if you had relied on someone else to fly it, or if you'd relied on someone else to do, the survey or you're on site setup, you might be scratching your head for days trying to figure out where the problem is. So, kudos to you for sitting there and seeing that when you pulled up to the truck and said, this is loose. This might be my issue.
Yep.
And
And when I found that, I went back and checked a few and they checked back good, but I think it was some of the later ones that I didn't check, that I didn't double check. And I think those were the bad ones, but I couldn't nail it down in processing, so I just redid it.
yeah. And again, going back to my survey days in North Carolina, on the opposite side of the season when it was winter and I was out there in the cold and I was writing down all those angles, yeah, I'd fat finger one every once in a while. So now let's talk about confirming the quality of results. There are some ways to do that because, you use Correlator 3D. Do you use Correlator 3D? Do you use our tables and our information to confirm that, or do you go outside as well into something else?
Well, it's a good question. What I do is I stumbled across a product called Virtual Surveyor a couple of
Yep.
years ago.
Mm-hmm.
I have found that to be a nice double check on and confirming everything.
Yep.
And it really allows me to act like a surveyor and throw in break lines before I triangulate anything.
Mm-hmm.
And it's a real comprehensive product for me. And that's where I do all my calculations,
Okay. Yeah.
quite candidly.
And there's absolutely nothing wrong with that. In fact, before I came on board with SimActive, I was doing this and using the software, and I had my routines in QGIS to pull in the surface and run it against the checkpoints and all of that. And actually, this is about the time that Virtual Surveyor started up, so it is a similar way to do it. However, in Correlated 3D, again in the demo, I'll show that we do provide results at the AT process. So when you finish the AT process, it gives you, the GCPs that were measured, the XYZ values, and how often the deltas they were, how on. The same with the checkpoints. So you can see right away that you've got.
Yeah, and I use those extensively.
Yeah.
I look at those quality reports in pretty much a lot of detail.
Yeah. And a lot of folks, maybe the quality reports are just quality report we provide. We're an international company, so we try to give you the basic information so that you can use it in other software or visually just understand. Yes, I've got good results. So you can always take that information, and if, say, for example, if you're using an SSDA spreadsheet on accuracy, you can just roll those values in there, create an accuracy report that maybe somebody else is more used to. So
Right.
it's not a fancy report with gray shades and all kinds of things that look like a PowerPoint. It's a report based on a CSV, and it's very easy to understand.
Now, Eric, just so you know, that report has saved me a lot of times because when I started this process, the executives of my company were very skeptical that a drone could do what we thought it could do. And one of my first steps in presenting something to them is when there's a problem, they'll say, well, show me, why do I believe that you're accurate? And I show them these quality reports and say, look, I've got 12 control points. Look at the vertical and horizontal accuracies on each of them if you want to.
Yep.
And I just hand it to them. And, when I started this process, I flew a site that was the largest home builder in the US. And we bid the project. And the first time I flew after all the clearing was done, I said, we got a big problem. And we were 90,000 yards heavy.
Mhm.
And for people that don't know, that's a very expensive problem to have.
Yeah.
That's upwards of $1 million problem. They didn't believe me. I used your process to show them that I was right. They brought in an independent guy and flew the site, paid him 8,500 or something like that.
Mhm.
And we were within 0.5% of the dirt numbers
Yeah.
using your process versus what they thought was a better process. And from that point on, they've sort of trusted me.
Yeah.
And it's been a good relationship. But your quality report is always the first thing that I show them. Like, here's what I did recently.
Mhm.
Here's my values. Here's the quality report to back it up. And then we'll start looking at it.
Well,
So
and,
it is a key tool that I use.
yeah, and it's really nice to hear that somebody else came in independently and validated what you did. That's
Right.
that's
I
outstanding.
encouraged them to do it.
Yeah.
I was really excited about them doing it because I knew I was right.
Yeah, that's great. And $8,500 is way better than a couple $1 million.
Yeah.
So that's
Right.
well worth it. So yeah, that's fantastic. I think that's really cool. And then we also have because once you have an AT solution, you're on your ground control, everything fits. Again, even if you used RTK or PPK and all you were doing is using those as checkpoints, if everything fits, then you're going to create your surface. And the surface is based on the AT, but we also still allow you in correlated 3D to check the control against the surface that you created. So you can have a double check to say, did anything change when I created this? Now, granted, you have got distance between points, and the software, is supposed to create the best surface based on that AT. So, it will. One of the things that people run into every once in a while is they'll convert the DSM into a DTM, so they'll have it smooth out an area. And what they don't understand is when you smooth out an area, you're taking elevation out, even if it's only
I'm not a fan of it.
Yep, exactly. Even if it's only a minute areas, you say, I'm just taking out the construction buildings or something like that. Well, not necessarily. You might be taking out more. And I always tell people, if you're going to create a DTM, then have it in correlated 3D, save out to a different file all of the information that it removed. So that way you can go back and look and say, it took out more than I
Right.
want. So, for people that are doing work like you're doing, yeah, you want to work with the DSM.
Yeah. And just so you know, Virtual Surveyor warns about using a DTM and creating any volume calculations.
Yep.
For that reason.
Yep.
And ever since I went through that, and I was enthralled with getting a DTM because I felt like, oh, it's just going to be everything ground. And they weren't huge errors, but they were errors, sometimes 3 feet.
Mm-hmm.
And I asked the guys at Virtual Survey, what's going on? They were like, well, if you're using a DTM, here's your problem.
Mm-hmm.
And from then on, I've DSM the whole way,
Yep.
every single time.
Yep. And just for people that may not be aware, Virtual Surveyor basically adds that capability for you to bring in your DSM. You could do a DTM, but bring in your DSM, bring in your orthos, and then you can start doing some break lines and things like that. So you can create a 10 rather than just a grid. And that will improve your results in certain areas. So great product. It's what we used to do in the old days of photogrammetry, where we set up the stereo plotters, and looked at it in stereo and did it by eye. So,
right.
Fantastic stuff. So we've covered everything in the webinar. You have a minute here. Do you have any other questions? I see you've got your drone behind you. You talked a little bit. You talked a little bit about possibly LiDAR coming up.
Yeah, we purchased the M350
Mm-hmm.
and we got the L2 sensor. And what we're hoping to do with that is a lot of what I do involves educated guessing.
Yeah.
To put it plainly. And that educated guesswork really manifests itself in trying to figure out before any of the ground is cleared, what really exists. And typically, an engineer is giving us an existing grade surface and a final grade surface in a CAD file.
Mm-hmm.
And we've sort of nailed down where some of the error in our bids has been occurring, and it's in the accuracy of those existing ground surfaces that are provided to us.
Mm-hmm.
Number one, they're pretty old, sometimes 6 or 7 years.
Yep.
And I looked at the metadata on some of those that are being delivered to us, and they're only guaranteeing accuracy within 14.5 centimeters,
Yeah.
which is 5 inches.
Yeah.
So that's a big difference to me. So what we're trying to do is fly the sites ourselves using the LiDAR drone and coming up with at least a better and more accurate surface, because we're involved in the making of it.
Mm-hmm.
And I've gone through a couple of demos with the manufacturer, or excuse me, the vendor who's selling it to us. And I'm confident that we can get there. I even used Correlator to get one done.
Mm-hmm.
Through an appointment, had you guys create a point cloud for me.
Mm-hmm.
And put that in virtual survey, and it came out really nicely. So we're optimistic.
Yeah.
It's a technology we're not that familiar with, but we're going to learn it.
Yeah. Well, yeah, it's once you go towards LiDAR, obviously things get more expensive. They get more challenging. But again, you still probably want control and checkpoints just to validate what you're doing. You did mention that correlated 3D, we do create a point cloud. It's an image-based point cloud. So it's still something that you can bring into, like you said, virtual surveyor and pull good surfaces from. Depending on what you're doing, it may be comparable to LiDAR. So that's nice to have. So for those that don't know, I think we did an update early last year, around this time last year, where we enhanced our point clouds to work a lot better. And man, have we got some things coming. So that'll be nice for everybody, and you'll see it soon in updates. But correlated 3D makes it easy for you to bring in data. It could have RTK, it could be PPK, or just ground control. It works for you. And in fact, like you said, LiDAR, we can bring in a LiDAR surface. So we can work with that as well. And you're right. The challenge sometimes is that when people give you data that's previously been collected to compare to something that you did, you really have to look at the metadata and see what the accuracy was of that data set. So, again, that's where you do your own investigation and you find out, where the potential problem would be. I will go ahead and move into the demo side. I just want to say thank you for joining us. I'm sure we'll be in contact soon as Chris and I get back and forth together quite a bit via messaging and email.
Yep.
So, Chris,
I'm a pest.
yeah, thank you very much for your time. I appreciate it.
All righty. Thank you.
All right, everybody. So let me get Correlator 3D up and running. Here we go. So let's walk through the project setup options. So if we go here to File, New Project, we've got our options, and based on the camera that you're using or the sensor that you're using. So we'll take UAV and we'll go ahead and load some images. Now, of course, if you had multiple cameras, you can change that here, but we're only using one. Now you can add them as individual files, or you can add the entire folder. We'll go ahead and add a folder. And we have imagery here. And you're not going to see anything. It's just you're just going to select it, and it's going to load all of your images. So here we have options in the setup. So just across the bottom, we can see this is the image name, where it comes from, the longitude, latitude, altitude, and then here we would have your roll, pitch, and yaw, omega, kappa, phi. But as I mentioned again in the conversation, that most drones don't really have IMUs. In fact, the roll, pitch, and yaw may be of the craft. And if you've got a gimbaled system, it may not even be giving you right results there. So be aware of that. Here we also have camera rotation if you need to rotate the camera, but you won't. Here we have, again, your roll, pitch, and yaw. It's latitude, longitude. It's in meters. And you could change this to feet. But more importantly, here is altitude / geoid offset. So if you know that you have an offset, you can drop that in here. It doesn't do anything physically to the image data. It just applies an offset. So again, you can get that from Trimble. You can get that, from your when you export your pause information to your secondary file. You can also get a offset from, many websites, NOAA, UNAVCO, all that. So those things you might want to think about. Now, if you're not using the EXIF data that pulled in with the camera, then you would load a file here. And here, for example, we can go up to, and we've got a pause file here. And let's just see if we load that. Yep, that's the file. But if you look at it, it's not been set up properly. So example, 1 is unassigned. This is actually the image numbers, but the image numbers don't correlate to the image names. So there's going to be a problem there. This looks like that is your coordinates. This, I'm not sure. That's probably the coordinate system used. We got 46 north. And then -2, -1E, unassigned, 83, 84. Here you've got information, you've got a lat long. So you've got a bunch of stuff in here you can work with. Something here that look ELH, so probably ellipsoid. So you've got that as well. And then these are unassigned, that's probably your omega kappa phi. So you've got all that. Now, if you're going to create that file, and we can look at it real quick in the folder, pause information here. And again, I believe it was this MRK file. Before you do anything, go ahead and create your header file here and name the things that you need named, eliminate the things that you don't. Make sure that your file number name is the same as your image name. Otherwise, they won't come in. So I'm just going to assume that these were applied. And we're going to use the original information. So let me go ahead and get rid of that. And I'll probably have to back out. Let me back out real quick. Add a folder, imagery. Here they are. And again, this is what I'm talking about. The 001 correlates to the 1 in the export file. Unfortunately, you need to have the entire name. So make sure that at least the image name is the same all the way through. So it is here in the excess of information. So we'll go ahead and use that and we'll import it. We're not going to mess with the geoid offset right now, just because, again, think about this. If you're doing this work and you didn't fly it, you may not know 100% if that altitude offset has been applied. So I'm just going to go ahead and say, okay, I'm going to add these images. And we know this is in North Carolina. So we'll grab that, hit okay, add. There we go. So now we have everything in and it's ready to go. So let's go ahead and select next. Now we can leave all this information the same. Correlator 3 is going to pull all of this in, so we're good there. And then we're going to create a project folder. So you're going to create your project folder. Of course, I already have one here, so we can go ahead and skip that part and we can move on to that data set that I've already captured. So let me grab that real quick. And we'll just open it right up. So here we are with the data set. And we've run the AT. So let's go ahead and load that. And we can look at the initial. So here's the initial. It's what we brought in. Now, we did set this up as RTK PPK assist. So if we look at step 1, the photo centers did not move at all. And again, when we run RTK PPK assisted, what we're telling the software to do is do not mess with the position of the images, X, Y, and Z. Go ahead and mess with the omega kappa phi, because as I mentioned before, most drones, unless you're harboring a $50,000 IMU in it, are not collecting good IMU data. So we can allow the software to adjust position, not in XYZ, but in OPK. So if we look at the results of step 1, and we can display the quality report. Here we have excellent results, and we're in the right projection 2264, and it was a DJI M3. Now, we have not run it against any ground control points. Okay, so this idea that you can do, mapping without ground control points, yes, you can. And it can look great. And what you produce from it can look great in the relative world. But the minute you try to tie it to the ground, you need to check that. So just to point out, again, we've not done anything to X, Y, and Z. We've allowed omega kappa phi to float. And what it's done is it's gone from, a little bit off in residuals to right on in residuals. So that is all good information. So the next step would be to bring in the ground control and check against the ground control. Make sense? So let's go ahead and do that. And again, I've processed that. So I can do that here. We've got our ground control points and they're set in as GCPs. And again, assuming you're doing RTK PPK, what you want to be doing is checking against the ground control, not actually using it. So let's go ahead and take these and move them from GCPs to checkpoints. And all we have to do is go here and say, you are now at checkpoint. And we can do that for each one. You are now at checkpoint. You are now a checkpoint. Okay, so now we have them as checkpoints and we can go ahead and run the bundle adjustment one more time. Actually, what I'm going to do is I'm going to delete the previous step. Okay, now we can go ahead and run the bundle adjustment with those checkpoints and we'll run it. And here again, I want to show you, we're going to do RTK PPK assisted. Now, if you're flying an aircraft or you're flying something with a Regal sensor or a Leica sensor or something like that, not a drone, and maybe you've got a LiDAR unit attached, maybe you don't, but you do have a precise IMU, like a Novatel or a Trimble, then you could go to full AT constrained. And what that means is that you trust your IMU, you trust the position of the images, not only in XYZ, but also in OPK. Then you're going to use full AT constrained if you want. Okay. RTK PPK assisted is what we're going to do because we're using a drone and supposedly that drone has good data as far as XYZ. We also have ground reference. So it says ground control points, but it also means checkpoints. So we're going to say that we're using these as a ground reference. Now, when you do that in Correlator 3D, if they're ground control points, then in the AT solution, in the bundle adjustment, the software is going to recognize that ground exists. And is there a difference between what the photogrammetry says should be the ground and what the ground control point is? So let's go ahead and we'll process that. Okay, so I'm going to skip ahead. We have the processing done. So let's go ahead and look at our AT report. Everything looks green and good, but we have a problem. And that problem is we're off by 104 feet. So what that tells us is that when we look at the checkpoints and we scroll down here again, and we see all that, and get to the bottom, we can see that we look at our checkpoints. Here they are. And we have a Z error of about 104, 105 feet. So what does this tell you? This tells you that the EXIF data did not include a geoid offset. What happens then if, for example, you captured this project with RTK, PPK, you didn't have any checkpoints, you went and delivered it to the client, and the client comes back and says, whoa, we're off by more than 104 feet. You're not going to feel too good about that, and they're probably not going to feel too good about or confident in your work. Now, this is the beauty of imagery. You can fix this problem, but you can only fix it with ground control. You could only spot it with ground control, and now you can only fix it with ground control. One thing you could do is you could go back and you could reprocess your positioning information and maybe to the ephemeris, and then you could get the geoid offset for that area, and you could apply that geoid offset again, like I said, in the beginning of the processing. That's one way to solve the problem. You're still going to want to use your checkpoints to see, is this a good solution? We'll go ahead and just say okay to that. And I'm going to back out of this step and say, that didn't work out. It tells us that we've got an issue, but we're going to let that lie for now. Let's delete this step. And the reason I want to delete it is we're going to go a different route here. So the first thing we're going to do is we've already measured these checkpoints. So let's go back and turn them again back into GCPs. And the reason for that is because I want you to see what happens when you use an RTK PPK solution, but you use your control as GCPs as well. So now they're all back to GCPs, and we're going to go ahead and reprocess the solution again. RTK, PPK, assisted, ground control points. We've changed them to GCPs, so we're going to go ahead and process it and see what happens, because I want you to see what the error might look like if you do this. And again, we've processed this, so let's go ahead and look at the results. And then, of course, graphically right away, you see problems in the results. And we'll go ahead and look at the report. And the report will show you that the assessment is poor. The Z error is better. And that is because the software is trying to pull down to control the data set. But on the other hand, it's being told to hold those values, the XYZ values. So this is giving you an obvious error, and you want to be aware of that if you ever see it. And it looks like this, especially around your control points, you've got a problem. And a way to solve this is to let go of the RTK, let the software process it full AT unconstrained, and see how it fits. So let's try that. We'll back off this step. And we'll do it one more time, full AT unconstrained with ground control points, and process it. And what we're trying to do here is just to see if the ground control points are good. All right, so now we have processed it full AT unconstrained using the ground control points. And they're right here, they're GCPs, so we used them. And let's look at our results. Here they are. We now have excellent results. And we scroll down and we look at our XYZ error. should be right here. Now we are about as tight as you can be. So this is validation that there was an issue with the images as they were imported. And that's because the pause data that they had was either off or a geoid offset was not applied properly. This is why I'm saying, because you have imagery and you have ground control, you can always fix the problem. Now, granted, 3 ground control points aren't the best that you would want to use, but it's something that you can work with. Clearly, a greater amount of ground control points spread out across the project or used as checkpoints would be ideal. But at least we know now that the imagery is good, the ground control is good, the solution is good. You can go ahead and create the product deliverables that your customer wants in the accuracies that they need. So let's now move on from talking about assessing quality to our last item, which is looking at using a DSM versus a DTM when you're working with surface data. So surface data, and let me go ahead and get out of this. So we have created a DSM and a DTM, and we can look at that. Let me go ahead and take us out of AT. And we'll turn on the DSM. Let me go ahead and turn off the images and the mosaic. And here is our DSM. So it looks good. And ideally, when you're doing something like land development or construction sites, the land is clear, the land is clean. So the surface that the software creates is going to be optimal. And what we would normally use DTMs for is to eliminate the trees, eliminate the structures, things like that. So for example, if we just zoom in a little bit to an area here, and you can see we've got a few items. It looks like we might have a bulldozer here or a vehicle here and so forth. If we look at the DTM that was created, and again, we're looking at the same area, you can see that it's cleared out a lot of those items, the bulldozer, the trees, and things like that. That's great if you're going to create a contour model, not necessarily if you're doing takeoffs or things like that. And the way we know this is when I created this DTM, I elected to save the difference. And you should do this. And we'll look at that. These are all the items that were pulled as non-surface material and taking it to the ground. So that's great. It eliminates the trees. It does all that stuff. It actually eliminated the vehicle here, but it does do minor removal in areas where it may not need to. So be aware of that and be willing to either put that back in by cropping it and then merging it back in with the DSM, or just work with the DSM when you're working with land development and construction issues. So very important that you keep that in mind so that you're getting optimal ground for what your project requires. And again, we'll go back to the DSM. Here it is. And you can see the full surface. And you notice that, it took off a little bit of the tops of the hills, things like that. You just have to be aware of that because it's really intended to eliminate trees and maybe a car or something like that. So you have to be aware of that. Anytime that you're going to take this data out into something else like a virtual surveyor or QGIS, and you're going to draw break lines, and from those break lines, you're going to create a tin, you want to use the DSM surface. So with that, I think we've covered everything in the demo that we talked about in the webinar. I'd like to thank our guest, Chris Greene, for joining us. I'd also like to thank those of you that attended the webinar. Again, if you submitted a question during the webinar, I'll make sure to get those answered for you as soon as possible. I'd also like to remind everyone that this webinar, as well as all of our previous webinars, are available on our website, simactive.com, where they can be found under the Learning tab. Additionally, this webinar will be converted to a podcast and made available in the next few days. Thanks for joining us. Until next time.